Hey y'all. So I was gonna finish up some a little bit of discussion on law of exponents. So I wanted to go over a couple things right there. So I've already written down some stuff in algebraic form that we can kind of discuss over, and I'll also do it numerically. So this is what I did yesterday during my class. So we had all of what we basically are going to be seeing in the law of exponents, and I broke everything down and proving them with numerical values just to show you that it is in fact true. The big one though for the first part, the first part is going to be a to the 0. So anything to the 0 power will always be 1. It doesn't matter if it's 3, it could be a negative value, it will still always be 1 no matter what the situation is. Now you will get into more complex problems, so if you have something though that you're multiplying by that's also to the 0 power, it doesn't just automatically make that whole statement 1. So you could have, for example, something along the lines of 3 to the second a to the 0. What this is actually saying right here is that this is 3 squared times a to the a to the 0, which I'm gonna have to write on a new line. I apologize. Let's just write that right below. So what this is saying is 3 squared times a to the 0. So a to the 0 is going to be 1, and 3 squared is still going to be 3 squared, which is 9. So in this case, it will be the answer when we simplify this expression would be 9. The whole thing would not be 1. I've saw that as a couple of mistakes as I was looking through some students' work today. So remember that the exponent is attached only to one of the terms, unless it's in a grouping symbol. And then if the exponent is outside the grouping symbol, the exponent is applied to the entire group. In this case, these are separate terms. So please do remember that. Just in case, for room's sake, I am going to just move this out of the way. So I'm going to grab this real quick. Apologies. Probably didn't take that 0 with me. I did not. So let's just attach that and then we're good. All right, so the other thing that we learned, this is the second item of business, was when we had the negative exponent. So what is this saying? It says that for any base a, again, that could be a number, it could be a variable, it could be anything along those lines, is raised to the negative n power, then we would write that as the inverse of 1 over a to the n. So these are applicable. So the most common situation that you may have seen this with is with learning with powers of 10, or when you're starting to be introduced to scientific notation. For example, if we have something along the lines of, and let's change this up. I'd like green. 3 times 10 to the negative 2. When we were to evaluate this, right, if you put that in the calculator, or if you do the shortcut for not system of equations, for scientific notation, you would bring the decimal point 2 places to the left, and you would get 0.03. Well, what's happening? You're multiplying 3 times 10 to the negative 2. What does this negative 2 represent, this 10 to the negative 2? Well, what this is saying is 3 times 1 over 10 squared, or 10 squared, which is just 100, and 3 times 1 over 100, or 3 over 100, if we were to simplify this even more, would give us 0.03. So when you have an exponent that is to the negative power, it's the same thing as having 1 over that base to the power, but it's a positive power. So if we were to have something simple algebraically, let's work something simple on that. What I am going to do is I'm going to go to a new page and we'll come back to this. So let's just do something a little bit more complex, and let's do D, and we'll do C. So let's just do a 2-term situation. So if we have 2 terms and we want to simplify this, the big thing is that we don't want to have negative exponents. So right now, d is already positive. So let's break this apart and look these at the terms individually. So we got d cubed times c to the negative second. Well, my d has a positive exponent, so there's nothing I need to change. But my c has a negative exponent, so let's rearrange that. So that's going to be d cubed still times 1 over c squared. When I multiply, we multiply fractions straight across, and so we simplify to d cubed over c squared. Now, I did tell my students, and I do apologize, if your teacher tells you to show that step, please do. But as we get better with this, we understand the concepts behind this, behind the law of exponents, I tell them then you can very quickly just rearrange from here to here without showing that extra step. And just know that if it's a negative, we'll just bring it to the denominator. But if the negative is in the denominator, we're going to do the inverse. And just give me one moment. All right, sorry about that, y'all. So where was I at? So let's have something a little bit more complicated. Let's have let's do 4 terms this time, and let's actually throw an integer to be one of them. So if we're still doing with the negative exponent, so if we have something along the lines of 3c to the negative 4 d squared, and let's do e to the negative first. Please remember these are 4 separate terms, and the exponent is only attached to the base. It's not attached to every single one of these. It's only attached to what it is next to. Again, if it had been in a grouping symbol, it would be a different story, but again, these are 4 individual terms. So this is like saying 3 times c to the negative 4th times d squared times e to the negative 1st. So looking at each one of these, we'll go through. 3 has a positive 1. If it's just a 3, we know that it's just raised to the first power because it's just itself. But you don't need to write that, so I'm going to go ahead and erase that. So I got 3. C to the negative 4th is going to be like saying c 1 over c to the 4th, or let's just throw it in the denominator. D squared will still continue to stay up top because it's a positive. And e will move to the bottom because it's a negative 1. Now, this is the simplified version, and I did that really quickly without breaking it down because I skipped the tricycle step. If you want to see a breakdown of how that occurred, let's look a little bit over here to the right. So looking at each individual term, I still have 3 times 1 over c to the 4th times d squared times e, hold up, 1 over e. Now I purposely took away to the first exponent because that's already here, and that's just monotonous for us to go ahead and say that again, or repetitive. And I purposely put the multiplication symbols here because we're multiplying fractions, and if they're in the numerator, we can just put them over 1 and multiply straight across. 3 times 1 will be 3. 3 times d squared will be 3d squared. 3d squared times 1 is still 3d squared. Now for the bottom, 1 times c to the 4th is c to the 4th. C to the 4th times 1 is c to the 4th. And c to the 4th times e is c to the 4th times e, which is our answer down here. All right, so we moved our way up to a little bit of complex problem. Now, let's take a look at when we're multiplying things to the same base. So the next law is telling me a to the n power times a to the m power. If we're multiplying things at the same base, again, it could be the same variable, the same integer. It doesn't matter. As long as the base is the same and their exponents are different, we can just add them as we multiply things the same base with different exponents. And why is that? Or how can I prove that? So let's prove that real quick numerically. So if I have 3 squared times 3 to the 3rd, that is like saying 3 squared, which is 3 times 3, times 3 cubed, which is like saying 3 times 3 times 3. Well, how many times am I multiplying 3 times itself? 1, 2, 3, 4, 5. So that's like saying 3 to the 5th. And look at that. If we add our exponents, we would get to the 5th. All right, let's make that a little bit more complicated. Let's use that algebraically. So I'm going to go to the next page. Let's write this one in blue. So this is when we're doing multiplication of the same base. So if we have something along the lines of x to the 4th times x to the negative 2nd. Actually, let's hold off on the negatives for right now. We'll get to that in a minute. Let's do x to the 5th. Okay, so I'll show the tricycle step. So what I'm going to do is I'm going to show it breaking down. X to the 4th is like saying x times x times x times x. And I'm multiplying that by 1, 2, 3, 4, 5, x to the 5th. And if I just multiply these all together, I have x to the 1, 2, 3, 4, 5, 6, 7, 8, 9. X to the 9th, which is the same thing as adding our exponents. All right, let's take it up another notch. Let's actually use one with a negative exponent. So if we have something to the negative exponent, and let's make that negative exponent a little bit higher. Oh, not the same. Let's do to the, we'll do the 6th. No, let's do the 7th. All right. So I'm just going to do the shortcut. I'm not going to bother with writing. Well, I'll go ahead and write it out. Might as well. So we get x times x times x. X to the 7th, to the negative 7th. That's like multiplying 1 over x times 1 over x times 1 over x times 1 over x times 1 over x. 1, 2, 3, 4, 5, 6, 7. Now, if I want to use the commutative property of multiplication and kind of rearrange this to show you what's going to happen next, I'm going to move things around since we're just multiplying. And I purposely wrote them like this for a second. Let's move this a little bit further down. So. 1, 2, 3. 6. Now, the reason I did this is so that you can see right here, what's occurring is that we're using the multiplicative inverse. This is the multiplicative inverse. Using that property, we can see that x times its reciprocal will be 1. So it's going to cancel to be 1. Same thing what happens here. This is going to cancel to 1, and this will cancel to 1. So I'm now left with 1 over x to the 4th. Now, if I had just added the exponents, 3 plus negative 7 gives me x to the negative 4th. And what does that look like? It looks exactly like this. So we can still get the same answer. So I broke it down into its own separate factors, use the commutative property of multiplication to adjust it, so I can then use the multiplicative inverse property to cancel out things that are being multiplied by its reciprocal. And then what am I left with? I'm left with 1 over x to the 4th. And again, we could have just used the law of exponents. Since we're multiplying the same base, we could just add the exponents together. All right, let's go back for a second. And let's look at the power rule. Okay, so the power rule tells us then if we are raising something that's in a group to a power, then we can just multiply those exponents instead. So let's look at that numerically or with integer values. So let's use, I've been using a lot of 3 squared. I'm sorry about that. I'm just using easy numbers to help us out. So if I got 3 squared to the 3rd, that's like saying 3 squared times 3 squared times 3 squared, because I'm multiplying what's in this group times itself 3 times. And again, using the property we just, or the law we just learned previously, we have the same base. Let's just add them up. So we get 3 to the 6th. And if we had just multiplied 2 times 3, we would have gotten to the 6th. So again, just a little shortcut for us to do. Instead of having to write out all the factors together and writing in expanded form, we can be quick about it. Now let's make that a little bit more challenging. I think I might have run out of room here. Yeah, so let's work a little bit on here. All right, so we're going to start easy with just a single variable. I'm going to use somewhat low numbers. So what this is saying is x to the 4th times x to the 4th. And then using the product rule as we're multiplying things at the same base with different exponents, we can add them up. So that's x to the 8th. And if we had just multiplied 4 times 2, we would have gotten the same answer. Let's make it a little bit more challenging. Let's actually include a second variable. And this time I'm going to just leave it to the y. And again, I'm going to square it. So, breaking this up without multiplying, without using the power rule, we'll hold off for a second. Let's see what this looks like. This is x to the 3rd times y times this group again times itself, because we're doing it twice. So how many x's do we have? Well, we have 2 x's, so let's rearrange this so we can get them closer together. So now, seeing with everything that has the same bases right next to each other, we can add up our exponents. We get x to the 6th and y squared. So this would be our answer. Now, if we had just multiplied, we would have multiplied 2 times 3, which would have given us 6. And here, this is y, but it's y to the 1st power, so 2 times 1, which gives us 2. And the same thing would occur even if these were positive or negative values, if we included integers, as well as that, the same process would occur. So it can get more challenging with that, but this is at least the basic overview for this. The last one is the quotient rule. So that's saying if you have the same base, you can take your exponents and just subtract them. So let's take a look at that. So if I have 3 to the 4th over 3 to the 3rd. Let's do the 4th. I mean to the 5th instead. So what is that saying? That's like saying 3 times 3 times 3 times 3 times 3 over 3 times 3 times 3. 3 cubed, 3 times 3 times 3, 3 to the 5th, 3 times 3 times 3 times 3 times 3. And look at this. If we do 3 divided by 3, that's like our factoring thing when we're trying to reduce or simplify a fraction. These cancel out to be 1, cancel out to be 1, cancel out to be 1. What am I left with? 3 squared. And if I had subtracted 5 and 3, I would have gotten the same answer. All right, let's make it a little bit more challenging. So let's go with just a single variable first. So I'm going to go ahead and write this out just to show to you that it is going to occur the same thing if we subtract 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over y times y times y. We cancel, cancel, cancel. We're left with y to the 1, 2, 3, 4, 5, 6, 7. And if we had subtracted 10 and 3, we would have gotten the exact same answer. All right, what if there's more than one variable or more than one term? again, you just match up with what you know. So sometimes you'll be given like 3 variables that are the same in there. You maybe only be given 2 and 1 that's different. So just pay attention to the problem. So let's do something a little challenging. Let's try 3. And let's also include a negative. And let's, we'll start with just division for right now, but then we're going to combine them all together just to kind of take care of stuff. And you know what? Let's make this a 6, and we'll make this an x to the... We'll make this also a negative. Make it 9. And we'll also match up a 4 or a y with this. Okay. So let's focus on the integers first. So we got 3 divided by 6. What can we simplify that to be? So if it's 3 divided by 6, we could simplify this to 1/2. So I'm going to go ahead and use 1/2 to start off with. Okay, so I've simplified the integers to be 1/2. Now let's look here. -5 minus 9. -5 minus 9. So if we have x, -5 minus -9, this would be x to the 4th. So where's x to the 4th going to go? At the very top. Oh, and you know what? Let's actually make one of these. Let's make this and let's result this in a negative. So let's do y to the, we'll do to the 10th still. So if I have my y, which is to the 4th, minus 10, I get y to the -6. Where's the -6 going to go? Well, if we want it to be positive, we're going to throw it to the bottom. Now, if you don't realize that right off the bat, that's okay. You know what you do? Let's rewrite this real quick. So let's say we didn't realize that if we get a negative, that we just automatically put it at the bottom for that. Well, this is what you do. We have our 1/2, we have our x to the 4th, we got our y to the -6, and then just simplify from there. And I should have gone the other way. Let's point the arrow the other way. So we would go this way. So x to the 4th times 1, x to the 4th, 2 times y to the y to the 6th, because we're going to put this over 1, be 2 y to the 6th. Okay, so you can do it that way as well. If you happen to forget, if you see the negative, then to automatically just bring it to the bottom. All right, let's try one more thing that you're going to see that I'm going to briefly go over, and I'll probably go over this as well tomorrow with class, with scientific notation that kind of combines our multiplication rule for exponents. So if you're given two values that are in scientific notation, you're multiplying them. What you're going to first do is you're going to look at the first factors. Now, remembering with scientific notation, your first factor is going to be the numerical value out front. You're going to go ahead and multiply them. 6 times 7. Or actually, let's look at this a different way. Let me take a break for a second. Let me look at this way. So let's just go ahead and think about what's going on. We're multiplying 6. We're multiplying that by 10 to the -4th, and we're also multiplying 7 to that, and 10 to the 5th. So since we're just multiplying completely across, you know what we can do? We can rearrange this. We can rearrange this instead. So if that would help you out to see why we can just multiply the 6 and the 7 right off the bat. So again, using the commutative property of multiplication, I can rewrite this as 6 times 7, and that's going to be times 10 to the -4th times 10 to the 5th. And so now I have my bases that are similar together, and I have my integers together. 6 times 7 is going to give me 42. Because these have the same bases, I can just add the exponents, and I get times 10 to the 1st. But I'm not done. Why? because this isn't in scientific notation anymore. We have a double digit. We have a double digit in the front. It needs to be under 10 or greater than or equal to 1. So what I'm going to ask you to do is you're going to take anything that may be, if it happens to not be in scientific notation anymore. And what I mean by that is it's not below 10 or greater than or equal to 1 for your first term or your first factor. You're going to rewrite just that term in scientific notation. So we're going to put parentheses and rewrite 42 in scientific notation. And how would that look? That would look like 4.2 times 10 to the first. And then we're going to pop everything else that was left times 10 to the first. And then again, we're going to simplify. We got a 10, we got a 10. So what does that mean? We're going to combine, we're going to combine them. Sorry about that, y'all. So we got 4.2 times 10 to the first times 10 to the first. Bases are the same. So we add the exponents and we get 4.2 times 10 to the second would be the result of this product. Now with scientific notation, I'm going to be okay with you leaving it if you're just doing scientific notation. And again, you will know you're doing scientific notation because you will have a base 10 factor, as we see here. If you're dealing with a problem with scientific notation, you can leave the negative exponent. But if you have variables with negative exponents, in that case, you're going to simplify it until you have positive exponents. And I'm sorry, let me reiterate that one more time, just in case I may have misspoken. If you have a negative exponent on a variable, you're going to simplify that until you have a positive exponent on that variable. If you're dealing with scientific notation, I am okay with you having a negative exponent on your base 10 because you do use negative exponents on your base 10 for scientific notation. So I briefly went through some of those problems. I apologize for taking the break there. Something came up all of a sudden, so I'll edit that out. But if you do have questions, please let me know. This is an overall encompassing video over everything that we are going to learn for the law of exponents. So please use this to your advantage on this. And if you have questions on how I did a certain problem, please let me know. I was looking at the practices that I was having y'all assigned for that, and I don't see anything too bad with the combining. I think we're going to be okay with that. Just pay attention if you do have more than one variable. Make sure you're paying attention to which variables are being used. You only combine the variables that are the same, just like how you would like terms, and follow those laws. If you do have any questions, please let me know. I hope you're doing well, and you have a good day.